Okay, so I'm gonna leave number 9 for you guys to do. So we've got what numbers did we do? 4, 7, and 9. Okay, so 4, 7, and 9. If you need help with those, let me know. Okay. Remember whenever we were graphing, guys, one of the things that we talked about was that um a lot of times you had that one solution where your lines crossed, right? Where they intersected. But sometimes you had other scenarios that happened. Let's say you drew one of your lines and then you drew another line and they were completely parallel. What happened? Well, there were no solutions, right? We wrote a NS, or you could write this symbol too. You could write the empty symbol. All right. Um, so graphically, it was really easy to tell, but algebraically, what happened? Whenever you were eliminating a variable and solving, both variables went away. Okay. And you were left with a non-true statement. Okay. So something that just didn't make sense, like uh 2 equals 7. That doesn't make sense, right? So you knew that there were no solutions if you ended up with something nonsense, okay? So the same here. Let's look at another scenario. You could have drawn one of your lines and then you do the other one, and it turned out that they were the same exact line. Okay, so we said that there were infinitely many solutions, right? There were so many points that those two lines had in common. Well, we're going to have the same thing algebraically from the start. Both variables end up going away. Both variables went away. And we were left with a true statement. Okay, so like maybe 5 equals 5. That's true. That's an example of that. So if we kind of keep that in mind, graphically, what happens when you have no solutions? Graphically, what happens when you have infinitely many solutions? They're kind of easy to see on the graph, but algebraically, you have to be able to make those conclusions. So let's do number 10 and see what happens. Everything's lined up beautifully. So I'm going to go ahead, and what it looks like, let me try and eliminate the 3x, the threes. I'm going to have to subtract, right? Because 3x minus 3x. So you're going to subtract everything in that second equation. So 3x minus 3x is 0. Negative 4x minus negative 4. If you have negative a minus, that becomes a positive, right? So negative 4y plus 4y is also 0. Negative 10. Look what happened, guys. Both of my variables went away. So something strange happening. Okay. I know I'm going to have one of these situations happening, but let's check it out. Negative 10 minus negative 13. That's the same as saying plus 13. So negative 10 plus 13 gives you a positive 3. Guys, does 0 equal, does 0 equal 3? No, it doesn't. We're left with something that's nonsense. So my solution is that I don't have one. I don't have any solutions. Okay, so let's check this guy out. I have 2x plus y equals negative 10 and negative y equals 2x plus 10. They're not lined up quite yet. Okay, so what I want to do is I'm going to write it in standard form. So I want my x's and my y's to be on the left-hand side. So I need to move that x over there. So my bottom equation, since this is positive on the right-hand side, when I subtract it from both sides, it becomes negative. Equals a positive 10, so I'll just write 10. I'm going to rewrite the top equation so that everything's lined up. This is looking very familiar almost, right? Let's try and eliminate the x's. 2 minus 2, so if I add those together, I get 0. Positive y minus y, I get another 0. Negative 10 plus 10, I get another 0. My variables went away and I'm left with a true statement. That means I have infinitely many solutions.